Okay, Smita, Swapna, good morning. Akhila. And I request Mohsina to stop your microphone, okay? Saranya, Disha. Okay, Ammu, Saratha, good morning, good morning. Mohsina. Avarna. Okay, Fatima. Mohsina, will you please switch off your microphone? Mohsina, are you there?
Hello, Sare.
Yes. Yes.
Sara Mohsina remove ചെയ്തോ ഞാൻ പറഞ്ഞോളാം വിളിച്ചിട്ട് പിന്നെ ഓക്കെ ഓക്കെ ശരി
Okay. Say, when continue with this testing of hypothesis on non-parametric basis, the next one we have to deal is x-square tester or chi-square tester. Okay. Say, x-square actually means it describes the magnitude of the discrepancy between theoretical and observation distribution. That means there exist two types of distribution. One is theoretical distribution, which is calculated on the basis of probability, and observed distribution, which is calculated by considering the samples under study. So we consider a certain groups of samples out of the population. That is one group of data. And we also make some theoretical distribution figures on the basis of the probability study. By considering these two types of figures, we analyze whether there exists any variation between our observed study and theoretical figures. So, x-square test or chi-square test is used to measure the variability or variance on the basis of the observed frequency and theoretical frequency. Okay. To get an understanding about this, you must have a knowledge regarding what is this theoretical frequency and observed frequency. It was already discussed in our previous hypothesis study also. See, theoretical distribution means the distribution formed on the basis of pure probability. And observed frequency means the frequencies, that means the figures we collected, the data we collected on the basis of our observation, observing the samples out of the population. Okay. It's actually a non-parametric test. And there existed definitely some assumptions about the form of distribution and the regarding the samples that we collect. Okay, there is a table called x-square table or chi-square table to test the value of the collected data. And we usually use the degree of freedom n minus 1 and level of significance is usually 5%. That means the point is 0.5. Okay. I explained this. This is the theoretical aspects regarding this Kaiser's test, and I explained this with the help of a question. So after putting a heading chi-square test or x-square test, write down a question. I detect a question now. Just write down a question. Okay. Put this heading chi-square test or x-square test and write down this question. A textile manufacturer interested in studying the customer preference for designing his product before commencing a commercial production. He conducts a survey of 100 customers all over the country and classifies their response in the following way. Design 1 -20, comma, design 2 1 2 means Roman letters. So provide Roman letters. Design 1 -20, design 2 put a hyphen 30, comma, no, and design 3 -18, design 4 32. I read the figures once more. Design 1 20, design 2 30, design 3 18, design 4 32. Use x-square test to test the hypothesis that the customers have no preference for any particular design. So that is the question. At first, you should have a clear understanding regarding the question. A manufacturer is studying the markets for various designs of product. He is a textile manufacturer, and he is interested to study which design or whether the customer purchase a particular product on the basis of its design. And he took 100 samples out of the total population, all over the country. Means excuse me, one second. So here the total population of the country is under study, and he is taking 100 samples out of that. And on the basis of that analysis, the result is like that. Design 1 is preferred by 20 customers. Design 2, 30, and design 18, design 3, 18, and design 4, 32. That's the data he collects. Okay. Now we have to tabulate this data in a particular format. See, I look at the table. Can everybody see the screen very well? Is it clear? Okay, Swapna. Okay. Now, our hypothesis is there any preference on any particular design? It is specified in the question that no preference for any particular design, isn't it? The hypothesis that the customers, we are going to test the hypothesis that there is no preference for any particular design. Okay, so the hypothesis that H0 is the null hypothesis, isn't it? H0 H0, can you see this? H0 is equal to no preference for any particular design. That is the null hypothesis here. Okay. Now we are going to check with the available data. See, so you have to write this H0. That means null hypothesis is equal to, everybody should write this H0. H0 means the 0 is put at the foot of the H. H0, that means null hypothesis. Null hypothesis is equal to no preference for any particular design. Now we are going to check this on the basis of the hypothesis. In the question, it is particularly asked to use chi-square test. We can use any type of test for this study. But here we are using the chi-square or x-square test for this. Okay. See, since 100 samples are under study, it's given in the question that the manufacturer is studying by taking 100 samples out of the population. So n number of items, n is here 100. Okay. And study, and the number of sample is equal to 100. And 4 design options are there. Out of these 100, the total study is conducted on the basis of 4 designs. Design 1, design 2, design 3. Okay. So number of designs here are 4. Okay. So the probability of picking a design by a customer is 1/4, isn't it? The probability of expectation, that means expected probability of each design is 1/4. As there is 4 designs and a customer will select any one out of that. So all of the designs have an equal probability to be selected. That is why the probability of each design is 1/4. Okay. This probability is used to find the theoretical observation or theoretical frequency. Okay. Actually, in order to implement this hypothetical study under chi-square test, we require 2 types of data. I already said that one is theoretical distribution and another is observed distribution. Theoretical frequency and observed frequency. 2 frequencies are necessary. The theoretical frequency is formulated by using probability study. Here, 4 types of designs are there. Total number of customers, total number of samples under study 100. And there may be equal chance to be selected. Each design has to be selected by a certain group of customers, and we are considering equal chance for that. So out of this 4 design, one may be selected by some group, isn't it? So the probability of one design to be selected is 1/4. I think you understood this, how we come this, that means come to this figure 1 by 4 as probability. Okay, and you should write this. You should write this also for getting clear understanding of this theory. Since I wrote this here, sometimes it is not clear, so I'm reading this. Since 100 samples are under study, comma, and 4 design options are there. 4 design options are there. The probability of expectation, that is what we call expected frequency or expected distribution, for each design is 1 by 4. The probability of expectation for each design is 1 by 4. Okay. Now we come to the X square test formula. The formula is, look at the screen, and then only you can write it properly. X square is equal to sigma. This sigma is applicable to the whole of this figure. Okay. O minus E the whole square divided by E. O minus E the whole square divided by E. And the sigma is applicable to this whole item. Okay. This O minus E the whole square divided by E. It's a sigma is to be taken. So sigma is applicable to this whole formula. O minus E divided by E. O minus E the whole square divided by E. Okay. Here O is equal to observed frequency. O means observed frequency, and E means expected frequency. Okay, observed frequency and expected frequency. Now we are going to solve this question. Say the data is tabulated here. Look at here. Design 1, the first column, design 1, types of design. Design 1, design 2, design 3, design 4. 4 types of designs are there, isn't it? What is the expected frequency or expected distribution of each item? Out of the 100 samples, the probability is considered, equal probability is considered to each design. So 1 by 4 is the probability. Okay, so 100 into probability, 100 into 1 by 4, which is 25. And this 25 is applicable to all designs because we are giving equal probability to all the designs to be selected. That is how the E value, that means the expected distribution or expected frequency value is 25 here for all designs. Got it? Now come to the next column, which is observed frequency O. Observed frequency O is given in the question, which is 20 for first design, 30 for second design, 18 third design, and 32 fourth design. So the expected frequency and observed frequency are here. Okay. Now look at the formula. We have to find a O minus E. Then it's the whole square. Then it should be divided by E. After that, we should take the total of that, which is sigma. Understand? These are the steps we are going to apply here. O and E are available here. E value is here, 25 each. O value is also here. O and E are available here. And what we require as per the formula, O minus E. So you should prepare a column O minus E. Okay. Thereafter, we require O minus E the square. So after finding this O minus E, this column is not filled here. Everybody, after getting a clear understanding this, do it yourself. Okay. So at first you have to prepare a column O minus E. Then that O minus E should be squared. That is here O minus E the whole square. Then O minus E the whole square divided by E. E means expected value, expected frequency. O minus E square divided by E. So everybody should prepare all these columns and finally take the total of O minus E the whole square by E. And thereafter show me the answer. What is the total of O minus E the whole square by E? Got it? O minus E, then O minus E the whole square, then O minus E the whole square divided by E. Take the total of the last column and show me the answer. If anybody have any doubt, just ask me. Otherwise, construct the columns and find the value. Mohsina says it is 5.92. 5.92 is the answer. Smita also says the same answer, 5.92. Okay. Okay, Shimja, John Joseph. Ajimu, Rohan. Fatima. So I think all of you got this answer, 5.92. Now we proceed with the next step. I already told you that the degree of freedom used for this is n minus 1. Okay, here the number of samples, we are not considering the total number 100 for this purpose. We are just taking the number of groups that we are considering under study. 4 groups are here. So n is equal to 4. Then 4 minus 1, 3. 3 is the degree of freedom. Okay. Since the 4 levels are, 4 groups are considering here. So here the value, the overall number of samples is actually 100, but we divided it into 4 groups. So the 4 groups are under study. Okay, Sharni. Okay. So n degree of freedom n is equal degree of freedom is equal to n minus 1. That means 4 minus 1, 3. Okay, and level of significance is 5%. Okay, 5% means 5 by 100. That means 0.05. Okay, and you have to look into the chi-square table for this purpose. Just a second. Look at the table here. This is the X square table, X square distribution table. Can you see this? And in this, on its left hand side, there is a column DF, means degree of freedom. Here, our degree of freedom is 3, isn't it? I explained how it becomes 3. And the level of significance is 5%. 5% means 0.05. So, under degree of freedom 3, we have to take the horizontal value, and 0.05 is the significance level. This is 0.05, and the vertical column is to be taken for consideration. And from 3, we are taking the horizontal intersection. Okay, so 0.05 and 3. These are the 2 points. 0.05 vertically considering and 3 horizontally considering. There is an intersecting point, and the value is 7.815. Okay, 7.815 is the table value. Now everybody write that. At a 3 degree of freedom, at a 3 degree of freedom, and a 5% significance level, and a 5% significance level, the table value is, table value means X square table value. X square table is used here. Okay, X square table value or chi square table value. The table value is 7.815. Okay. Now we got the value by using the formula which is called a calculated value. So here the calculated value you already found out, which is 5.92. Okay, 5.92 is the calculated value. Am I right? And here the table value is 7.815. Okay, so the procedure is that the table value should be more than calculated value. As we can say, the calculated value should be less than the table value. Then the hypothesis will be accepted. Okay, here the calculated value is 5.92 and the table value is 7.815. So the criteria is clear. The table value is more than calculated value. So we have to accept the criteria. That means the hypothesis, which is there is no preference for any particular design. That is null hypothesis, isn't it? So we are concluding this. So everybody write this. Since the calculated value 5.92 is less than the table value, table value 7.815, accept the hypothesis. That is H0 is equal to, there is no preference for any particular design. Okay, is it clear? Okay, Aji Rohan. And anybody have any? Okay, Smita, okay. If anybody wants to repeat any steps, just tell me now. Okay. Okay, now I give one more question. Everybody write this. Ready? A sample analysis of an examination results of 200 students were made. It was found that 46 students had failed. 68 secured third class. 62 second class, and the rest were placed in the first class. Are these figures commensurate with the general examination result? Which is in the ratio 2:3:3:2. 2:3:3:2 for the various categories respectively. for the various categories respectively. Is question clear?
The respectively means first two means third class. In the ratio.
Respectively means failed third class, second class, and first class.
Okay, sir.
That ratio denotes the 2 is to 3 is to 3 is to 2, isn't it? So the first two represent failed candidates, and the second three represent third class. Next three represents a second class, and the last two represents a first class. Okay. 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 I think you completed. Everybody completed the question clearly. See, same procedure. Just write one more sentence. Use X square test to verify the hypothesis. Use X square test to verify the hypothesis. Okay. So, at first you have to identify the data here. The total number of samples, 200 students, isn't it? That means in an area or in a country, several students are writing the examination. They are called population. Out of the whole people wrote that examination, just 200 were selected. That is what here a sample. Okay. So 200 students were taken under study. We can say that it is a sample. Number of students under study, that means their sample number is 200. Okay. But this sample number should be divided into 4 groups. Failed candidates, third class candidates, second class candidates, and first class candidates. Okay, in this way, we have to divide this 200 into 4 categories. So the probability ratio is given here. In our last question we solved, there is also 4 types of designs. You remember that first design, second design, these 4 designs are there. And there was nothing mentioned regarding the probability. So we provided equal probability to all the designs. That is why we taken 1/4 probability to each and everything, isn't it? Or we considered a 1/4 for first design, second design. A column is there. That means theoretical frequency, E column. Remember that? But here, the probability ratio is given in the question. So the probability here is 2 plus 3 plus 3 plus 2. That means 2/10, 3/10, 3/10, and 2/10. That is the probability ratio. Okay. In order to get a theoretical distribution, that means E value, you should get multiply 200 with the probability ratio. See, I'm not going to do this question here. You should do by by understanding the question. I am explaining the various procedures. The first thing, in the last question, we showed design 1, design 2, design 3, design 4, isn't it? In that place, we are using failed candidates, first class candidates, or first class students. Failed students are the third class students, second class students, and first class students. That is the first column. Okay. Then the next column, E. How we find out E? 200 into 2/10. Then 200 into 3/10. Similarly, 200 into 3/10. Again, 200 into 2/10. Understood? So that's the E value. Okay. Then O value is given in the question. Observed value is given in the question, which is 46, 68, 68, 62. Then rest. That means in order to get the rest of figures, you should deduct this 46, 68, and 62 from 200. Okay. That means 200 minus 46, 68, 62. You will get the rest of the candidates. Understood? I think it is Find that. You have to find that. Okay. Then you will get O value also. Now, both the E value and O values are available. Okay. So, degree of freedom and significance level is not indicated in the question. So, the same degree of freedom. Degree of freedom means number of items. That means number of groups. Here it is also n is equal to 4. 4 groups are here, isn't it? 4 minus 1, 3 is the degree of freedom here. And the level of significance is 5%. So the same table value that you got in the last question, I think it is 7.815. So the same table value is applicable here also. 7.815. Clear? If you have a clear clarity regarding these aspects, then do this question and show me the answer of O minus, show me the answer of x square value, s square value. If anybody requires any clarification, just ask me. Otherwise, find the x square value. I expected some doubts from your part, but nobody asked any doubts. Here, what is the hypothesis H0? Anybody? What is hypothesis H0?
Observed figures commensurate with the general examination result.
Yeah, of course. The sample figures commensurate with the general results, general examination figures. That's the null hypothesis here. Okay, somebody showed the value, but I didn't notice that. Can you show once more? What's the value of x square? That means total value, total column, total of the last column. 4.82. Musina says the x square value as 4.86. Aji Rohan, it is not 40.43. No chance of that. O minus A the whole square divided by E, isn't it? Each one shows different answers. Check your figures. 8.42. Mariam says 8.42. I think that is the right answer. 8.42 or 43. Ammu Govan. Yes, that is the correct answer. Kartu, 8.42. Maybe 43. When you rounded up that figure, 8.42 is the correct answer. I asked you x square value, 8.42. Okay, Kavya. So, all of you got the, I suppose that all of you got that answer 8 point something. And the table value, it is already, Ajirohan, can anyone please list out the E value? Say, anybody tell me the E value? Adi request to check the answer. Can anybody say the E value? 40, 60, 60, 40.
60 and 40.
Oh, yes, 40, 60, 60 and 40. That is the E value. O value. O value. O value. It's given in the question, isn't it? O value is given in the question, Aji. What is that? O value is given in the question 46, 68, 62 and
24.
40, isn't it? 40. Okay, Ajirohan. So everybody make the calculations clear. And because of limitation of time, I'm moving to the next topic. So if anybody require to explain any steps furthermore, then just ask me. Okay.
So now the calculated value is greater than the table value.
Yeah, of course. Here the the conclusion is the calculated value. The calculated value is 8 point something, isn't it? And the table value is only 7 point. Then we have to reject the hypothesis. Here the calculated value is greater than the table value. So the conclusion is that we should reject the hypothesis. Clear? Okay. Now we are moving towards another topic. And somebody asked me to explain questions regarding regression analysis. The last class. So I am moving towards that portion, regression analysis, which represents the analysis of data, analysis of statistical analysis of data portion. So now I explain what is a regression analysis. Actually, a regression analysis means the estimation or prediction of unknown value from one group of variable on the basis of the known variables of other group. Okay. For example, there are access to two groups of variables, x variables and y variables, or a variables and b variables. Two groups of variables are there. Naming the variables, that is not an issue. So there are access to two groups of variables, and we know the value of one particular group of variables, and on the basis of that, we predict the value of another a particular variable of another group. Okay, so there exist two groups of variables. Based on the values of one group, we predict or forecast the value of the variable of another group. Okay, this is very much useful as in business. For example, we collected the variables related to demand and supply. For the last 10 years, we collected the demand pattern and supply patterns from our historical results, because the results are there, the figures are there. We collected demand of last 10 years and the supply of last 10 years. Okay, then based on the supply, how much will be the demand of the next year or after 2 years? What will be the demand after 2 years or 3 years? On the basis of the present figures, we predict the future value of a particular variable. Okay, so this is the method we use. It's actually a statistical method, statistical techniques to find out or predict or forecast the value of a particular variable based on the value of the available variables. Okay, so that is what the theory regarding this regression analysis. Now I explain this with the help of a question. So everybody write down a question now. And besides this, in your syllabus, this regression analysis should be verified with the help of ANOVA table. ANOVA table means analysis of variance. There is one more topic there, analysis of variance. So we simply call it as ANOVA. This ANOVA or analysis of variance is also an important statistical tool to find that whether the test we found out is true or false, or whether there exist any errors in the analysis. In other words, we can say that if in every hypothesis, for example, in the last one we studied the X-square test, there is observed frequency and a theoretical frequency, isn't it? So the theoretical frequencies are there on the basis of probability, and the observed frequencies are there on the basis of our study, sample study. Two frequencies are there. We are comparing these two, and we arrive at a conclusion that the theoretical frequencies matches with the observed frequency or not. It is not, does not matches with the observed frequency. We are arriving at a conclusion on the basis of that, isn't it? So, but on after arriving this conclusion, even then there is a chance of some errors that crept into the analysis, testing analysis. Okay, this error, usually called a standard error, this error is also considered for this, and we put into or you use another statistical technique to measure how much error is there or how much matching possibility is there. That means arriving at furthermore clear conclusion. That is what we do with the analysis table. That means ANOVA table. ANOVA, A-N-O-V-A, capital letters A-N-O-V-A means ANOVA means analysis of variance. That's the full form of ANOVA. Okay. So along with this regression analysis, we use the ANOVA analysis also done in this question. We are going to do that. Okay. I think the concept is clear now. What is regression analysis? Regression analysis is used to predict or forecast the value of a particular variable in the future on the basis of the available values of a particular group of variable. Okay. Similarly, after finding this analysis, that after making this regression analysis, we check that whether this data is significant or not, or it has any error or not. We analyze that with the help of another variance analysis called the ANOVA, analysis of variance test. Okay. I am going to explain both these things through one question. So everybody write down a question now. Put a heading regression analysis, and then write this question. Suppose that a researcher is interested in consumers' attitude towards the nutritional diet the nutritional diet of a cereal, cereal, cereal. Okay.
What's it?
Consumers' attitude towards the nutritional diet of a cereal.
Okay, sir.
Cereal, cereal, wheat, rice, such a cereal. He obtains a preference rating. He obtains a preference rating scale ranging from 1 dislike extremely, comma, up to 9 likes extremely. Up to 9 likes extremely well. The data given below. Look at the screen. You can see the data, but I am reading this. 2 columns are there. One is preference rating, which is denoted here as Y in the question, and protein, because nutritional value is explained here as protein, which is X. 2 columns are there, Y and X. The first column is Y and the next column is X. Okay. So the preference rating Y is given like this: 3, 7, 2, 1, 6, 2, 8, 3, 9, 2. Clear? Now come to the protein, which is measured.
Once more. I can't see it, sir.
Yeah. Can you see this? 3, 7, 2, 1, 6, 2, 8, 3, 9, 2. Clear? Is it clear?
Yes, sir.
Okay. Now come to the next column, protein. Protein column is measured as X, within bracket X, and the figures are 4, 9, 3, 1, 3, 4, 7, 3, 8, and 1. I read it once more. 4, 9, 3, 1, 3, 4, 7, 3, 8, 1. Okay. Now write as paragraph. Write paragraph. Fit Y on X. Fit Y on X. Regression equation. And test the validity using ANOVA. ANOVA. ANOVA, capital letter. ANOVA. I suppose.
Did you say shift to Y on X?
Excuse me, Amu.
So you said Y on X. What Y on X?
See, I explain it later. The question is, this is a part of question. Fit Y on X regression equation. What Y on X means? It's a part of regression equation. Okay.
No, before Y on X, I can't. It's not clear. Y on X, what? Shift.
Y on X regression. Y on X regression equation.
Okay, fit. Okay, sir. Fit. Okay, thank you.
Okay. Y on X regression equation, and then test validity using ANOVA.
Okay, sir.
Okay. Is the question clear to everybody? Now I am explaining this. See, if you, okay, Ajimon, okay. If you look into that in the question, a researcher is conducting an examination regarding the nutritional diet of a cereal. Cereal means wheat or rice. These are different types of cereals, isn't it? He is studying the nutrition of that, and the nutritional item is measured here in the name as protein. How much protein is there? Okay, and it is said that he obtains the preference rating scale ranging from 1 dislike extremely up to 9 likes. That is the total number of items here. When you count the number of data given in the preference rating and protein, it will be 10, isn't it? 10 items are there. So that's nothing regarding the number of items. That means 1 dislike means 9 likes. So this proportion will have when 2 dislikes, 8 likes, isn't it? In this way, the attitude or preference of the customers are measured on a particular way, and the data is given. The total number of items is 10. That is what it is explained there. And it is asked to analyze this data on the basis of regression analysis y on x. Actually, regression equation is regression. There are access to two types of regression equation: y on x and x on y. And now it is asked to do y on x. That means how much variability is there in y variable due to the variability of x variable. Okay, so we are here we are going to predict, or I already told you what is regression analysis: predicting a future value on the basis of the present existing values of some other variable. Here x variables are there. On the basis of x variable, it is asked to predict the value of y. Okay, that is what here indirectly asked by asking you to fit a y on x regression equation. Okay, there is x on y also. I explained later. Now I explain how to solve this question. Okay. Look at the screen. Regression equation of y on x. We usually say that regression line of y on x. Regression line of y on x. That's the heading. Okay. And it consists of a core formula and two supporting formulas. One is, the core formula is y is equal to a plus bx. So everybody write down these formulas. The heading is regression line of y on x. Okay. The core formula is y is equal to a plus bx. And we can use this formula only after finding the value of the next two constraints. That means these two formulas. Sigma y is equal to na plus b sigma x. Sigma y is equal to na plus b sigma x. Got it? The next line is, next constant formula is sigma xy is equal to a sigma x plus b sigma x square. A sigma x plus b sigma x square. I think all of you finished this formula. Now we explain how to find this. See, leave the first formula there, and we are considering the next two one, and using simultaneous equation technique to solve this, find the value of a and b. We have to find the value of a and b. A and b are the variables here. We have to find the value of a and b with the help of the last two formulas. Sigma y is equal to na plus b sigma x, and sigma x is equal to a sigma x plus b sigma x square. Okay. And besides that, you have to find the mean of two items for making ANOVA analysis. Okay. And I explain it later. Now come to the table. See, the given variables are tabulated here, y column and x column. First column is y and the second column is x here, because it is as given in the question. That is why I wrote here first y and next x. Okay, y values are here. You have these values with you, and x values are also there in the question. Okay, now for solving these two equations, look at here two equation. We require, what are the things that we require? Sigma y. Sigma y means total of y column. Okay, then n means number of pairs. Number of pairs, how many pairs are here? Y and x pairs are here. 10 pairs are here, isn't it? So the number of item n is equal to 10. N is equal to 10. Then again come to the formula b sigma x. Sigma x means total of x. Sigma x means total of x. So you have to take the total of y column and x column. Okay. And if you notice the next formula, sigma xy is there. Sigma xy is equal to. So you have to find xy also. So in order to get xy, you have to construct one more column, xy column. X and y are available here. Y and x are available here. Construct one more column, which is xy. Each x and corresponding y should get multiplied and show or construct this column. Okay, that is what called xy. And then take the total of this xy, then you will get sigma xy. Okay, multiply x and y, each value of x and y, and then take the total of that. Then you will get a sigma xy. Okay, then sigma x is available here. Then sigma x square. In order to get a sigma x square, you have to find one more column, x square. Each x value should be squared. That means here first x value 4, 4 into 4, 9 into 9. This way, every x value should be squared and complete this column. And finally take the total of this column also. Then you will get sigma x square. Okay. So take the total of y, sigma y. Total of x means sigma x. Then find xy and take its total. You will get sigma xy. And square each x and then take the total of that. Then you will get sigma x square. Okay. Everybody find these values and show me the total of x square. Ammo says it is 261. 261. Smita says it is 255. Make the calculations correct because I already calculated the values here. 255. Yes, that is the value. I think 255. I also got that a value. 255 is the answer. Ashwati, Ranjusha, and others check their answers. See, I got these answers. Sigma y 43. Check your answer. Okay, sigma y 43. Then sigma x also 43. Okay, sigma xy was 247. Then sigma x square 255. These are the answers that I got. And check your answers. Verify that. Okay, Kavya, 255. Okay. Anybody require further time? I am proceeding to the next step. Is it required to wait for anybody? Okay, no reaction. So, okay, Fatima, okay. So, I once again tell you the values that I got. You have to verify that. If it is wrong, just tell me. Okay. Sometimes my answer may also be wrong. So sigma y 43, sigma x 43, sigma xy 247, and sigma x square it is 255. Okay. As there is no objection, I am proceeding with these figures. Look at here. See, what's our formula? Sigma y
Sir,
is
I
equal
got sigma xy as 256, sir.
sigma xy 247. I got it is 247. Just check it once more. What about
Sure,
others?
sir.
247, sir.
247. I got the same answer, 247. Okay, Amma. Okay. See. Okay, Ranjusha. Okay. See, this is a formula. Sigma y is equal to NA plus B sigma x. Okay. Now we are going to apply the values here. And in the next formula also, sigma xy is equal to A sigma x plus B sigma x square. Okay. So when we implement the values in this formula, it will look like this. Can you see this? 43 is equal to, 43 is the value of sigma y. Okay. 43 is equal to 10A. 10 means n. Number of items, 10 pairs are there. So number of item n is equal to 10. 10 into A, 10A plus 43B. Sigma x also 43. 43B. Sigma B sigma x means 43B. So that's the first equation. 43 is equal to 10A plus 43B. Okay. And the second equation, sigma xy, which is 247 is equal to 43A plus 255B. So these are the two equations. Okay. Now listen, we are using simultaneous equation technique to solve these equations to get the value of x, A and B. Okay. We have to get A, the value of A and B. Look at here. As per the simultaneous equation technique, you know that in order to get the value, we have to nullify any A or B. That means we have to convert the value of A or B as 0. We should convert the value of A or B as 0 when subtracting or adding these two equations. Okay. Since all the values here are positive, then it is better to subtract the first second equation from the first one. So I am going to subtract the second equation from the first one. But before that, in order to convert the value of A or B into 0, we have to manipulate any one of the equation. That means we should equalize A or B. That means either this 10A and 43A should be equalized. This 10A should be equalized as 43 or 43 should be equalized as 10. Otherwise, we can look here also. This 43B and 250B, they should be equalized. Here I am going to equalize this one because this is comparatively least figure, small figure. So I'm using this. Now I am going to equalize 10A and 43A. 10A is here, 43A is here, isn't it? And we how to equalize this 10A with 43A? I'm going to multiply this whole equation by 4.3. 4.3. Okay. When we multiply this 10 by 4.3, it becomes 43, isn't it? So, in order to convert this 10A into 43A, in order to convert this 10A into 43A, I am multiplying this first equation, whole first equation by 4.3. Okay, so the first equation into 4.3. Okay, then 43 into 4.3, I got this 184.9. You can check it with your calculator. Okay, if there is any error, tell me. So 43 into, and in between this, if you have any doubt regarding these steps, just ask me instantaneously. Okay. Don't take time to ask questions. Ask the questions immediately. 43 into 4.3. Okay, then 10A into 4.3, we got 43. Now it is equalizer. Then 43B into 4.3. It will be 184.9B. Okay. The second equation is kept as it is. That means it is not required to adjust the second equation. We just adjusted the first equation only to equate the 43A with the 10A. Now the equation is 184.9 is equal to 43A plus 184.9B. Similarly, 247 is equal to 43A plus 255B. Now, the thing is that the A values, the coefficients of A values are same. Okay. We did this step in order to make the coefficients of A factor or A values as same. Now we are going to deduct the second equation from the first one. So a minus sign is given here. Can you see this? 184.9B minus 255B. I got it is 70.1B minus 70.1B. Okay. You have to check the answer with yourself. Verify the answer. Okay. Then 43A minus 43 becomes 0. Then 184.9 minus 247. It becomes minus 62.1. Got it? Now, we got the final result as this. On both sides, there is minus. Okay. Then we can remove that minus. Now, the answer is like this. 70B is equal to 62.1. Isn't it? 70.1. 70.1 B is equal to 62.1. Okay. Then what's the value of B? B is equal to 62.1 divided by 70.1. I got the answer as 0.887. 8871. Is it clear? If it is clear, say yes. Show yes. And if it is required to explain once more, tell me. Okay, Smita. Okay, Ranjita. Shimja, Fatima. Okay. Okay, Aji Rohan. Okay. You wrote up to this? Everybody? We got the value B as 0.8871. Okay. Once more. Saranya asking once more to repeat. Which is to be repeated, Saranya? See?
Second 184 total.
184. How we got this 184? We multiplied the first equation by 4.1, isn't it? Sorry, 4.3. Every element of first equation is multiplied by 4.3. Thus, we got 184.9. Then 43A and 184.9B. Right? Is that right, Saranya?
Okay. Okay, sir.
Okay. Then the next step is we are subtracting the second equation from the first one. Look at here. That means first one 184.9B minus 255B. We are deducting that. Thus we got minus 70.1B. Okay. Okay. Is that you required to explain?
Okay, sir. Okay, sir.
Saranya?
Okay.
Okay. Similar 43A minus 43, 0. Then 184.9 minus 247. It becomes 62.1. Okay.
Okay, sir. Okay, sir.
Okay. Then we can rewrite this as 70.1 B is equal to 62.1. Then what is the value of B? B is equal to 62.1 divided by 70.1. That is what we got. 0.8871. Is it okay, Saranya?
Okay, sir. Thank you.
Okay. Now we got the value of B. Okay. Now we are going to find out the value of A from by applying this value of B in any one of the equation. We are considering the first equation, which is 43 is equal to 10A plus 43B. I am taking this equation. This equation is written here. 43 is equal to 10A plus 43 into the value of B is applied here. That means 0.8871 is applied here. Okay. Then I got 43 is equal to 10A plus When I multiplied 43 into 0.8871, I got 38.15. Okay. I picked this figure on from the right hand side to the left hand side. Then it becomes 43. When it comes to the left hand side, it becomes minus 38.15 is equal to 10A. I deducted for that must took the difference between 43 and 38.15, which is 4.85 is equal to 10A. Then the value of A is equal to 4.85 divided by 10, which is 0.485. Got it? I just applied the value of B in the first equation and found out the value of A. Got it? I know most of you know about this, how to solve this, but even if there is somebody who want to have any clarification, just ask me, okay? Now the equation is ready. I already told you that the core equation is y is equal to a plus bx, isn't it? Now this a value and b value are available. I applied these values in this figure. Y is equal to a plus bx. The value of a is equal to 0.485, isn't it? And the value of b is equal to 0.8871. Then the equation. This is the regression equation y1 x. Y is equal to 0.485 plus 0.8871 x. Y is equal to 0.485 plus 0.8871 x. This is the y1 x regression equation. In the question is asked to fit an equation, regression equation from y1 x. Now it is, the equation is here.
Sir.
Oh.
Sir, how to get 38.15?
38.15. Say, I took the first equation. Look at here. I took the first equation. 43 is equal to 10a plus 43b. 43b. Okay. In the place of b, I applied the value of b we got by solving the equation 0.8871.
Okay, sir.
Then 43 into 0.8871. That is the value of 38.15. Clear?
Yes, sir. Sir, value 37.84.
37.84. There is no such value here. 37.84.
No, sir. 43 into 0.88 equal to 37 point.
Is it 43 into 0.8871 is equal to 37?
Yes, sir. 37.84.
Okay. Then see, everybody check that answer. There is some slight error in this figure. Then check that and correct it. No
Sir, could you please explain again that y on x from y on x after finding a and b? Yeah.
What's the core formula for regression equation? Y is equal to, see this, y is equal to a plus bx, isn't it?
Okay.
Here y is equal to value of a is available. We found out the value of a, which is 0.485, right?
Yes, sir.
Then plus value of b is 0.8871, isn't it?
Yes, sir.
Then x is there. That is how this appears. Y is equal to 0.485 plus 0.8871 x. Understood?
Okay, sir. The x remains as x.
Yeah, x is there. X is there. Yeah.
Okay, sir.
That means in order
The
to find
value of
this equation says that in order to find the value, in order to predict the value of y, you have to just implement the value of x here. Okay. Just applying the value of x here, you can get the value of y. That is what depicted by this equation. Got it?
Okay. Okay, sir.
Sir, what is the value of A?
Value of a.
A.
I got it as a 0.485.
Okay, sir.
Okay. So the regression equation is over, and now we are going to the next stage for ANOVA analysis. And is there any question up to now? Here, this equation, actually, we are going to continue with this equation. Here, the equation is y is equal to 0.485 plus 0.8871 x. So, x is there. By applying the value of x, we can find each expected value or predicted value of y. We can predict the value of y by applying the value of x. Okay. I explained that how we find out that value. Now, is there anybody having any doubts up to now?
Sir, last step once more, please.
Which is the a plus y is equal to a plus bx. You want to explain that?
No. Not A. Last one, what you showed that.
Last one means this. Last one is this y is equal to, I applied the value of a here, which is 0.485. And then bx, in the place of b, I applied the value of b, that means 0.8871 x. So this is the equation. You want to clarify this in?
Okay,
Hello?
sir. I understood.
Okay. Now listen, we are moving towards the next point, which is ANOVA table or ANOVA procedure. Look at here. Everybody look at here. I provided a heading like this, ANOVA table. We should prepare this ANOVA table. Some parameters are here. See, source, degree of freedom, sum of square, mean square. In this way, sigma RSS, sigma error, then sigma TSS. In this way, several aspects are, several parameters are there in the ANOVA table. Okay, but I just introducing you how an ANOVA table looks like. Okay, now we come to this table after making a calculation. We need a further calculation to come to this ANOVA table. After that, we can write this and I explain that later. Okay, but you should remember these things, that we should have these values: RSS value, error value. Okay, then mean square, sum square. These things are necessary to construct this ANOVA table. Okay, now I explain how to find these values and put these values in the ANOVA table. Okay, now look at here. For this purpose, here it is required to fit a regression equation y on x, isn't it? So we are considering only y values for that. Y on x, since it is asked to find the value or regression equation on the basis of or based on y on x, I just took the values of y here. Okay, and we have to construct some columns: y cap, error, error square, TSS, and RSS. I explain how these values are constructed. These columns are there. But before doing that, you have to find out one more thing, which is mean of x and y. Say, in order to get a mean of y, which is noted here as y bar, a bar is there and y is written here. That means y bar. Y bar means y mean of y is equal to sigma y divided by n. Sigma y divided by n. In your table, you already found out the value of sigma y, isn't it? I think it is 43. So 43 by 10, that means 4.3. That is the mean of x. Am I right? And I also find out the mean of x. That means x mean. Okay, okay, thank you. X mean. X mean, to find out this x mean, it requires sigma x divided by n. Sigma x is there in your table. I think it is also 43. Then 43 divided by 10, that is 4.3. So both the mean values of mean y and mean x are 4.3, right? So everybody find the values. Just write that mean values. Just find out the y mean and x mean. That means sigma y divided by n and sigma x divided by n. Everybody find out, write on that. After that, we can proceed. Everybody write that. Right. Now, we are going to prepare this table. Plot y values here. Say 1, 2, 3, 4, 5, 6 columns are there. You should have a space for this calculation because we have 6 columns. Y cap, error square, TSS and RSS. Such a number of columns are there. I lead you from one column to next one. Okay. Now listen. 6 columns are there. The first column is given y values in the question. Everybody write these y values in the question. Make it fast. Time is running out. Everybody write down the y values in the question. It is 3, 7, 2, 1, 6, 2, 8, 3, 9, 2. And before that, I have to say one thing. If you feel any doubt, just clear immediately. Okay. Clear your doubts immediately. Only then you can proceed with that. Now, the next column is y cap. How we find out this y cap? This y cap is found out by applying the value y is equal to a plus bx. You remember the equation that we finalized as in the regression equation, which is y is equal to a plus bx. What's the value that y is equal to a plus bx? You remember that?
0.485 plus 0.82.
Yeah, of course, that value. See, take that equation. That means 0.45, 0.485 plus 0.8871 x, isn't it? Take that equation. Everybody listen. Take that equation. Y plus bx, that equation. Take that equation and change the value of x. Change the value of x. What is the value of x there? Take the table and the value of x there, which is 4931, isn't it? Simply changing the value. That means applying the value of 4 in, you will get the first value. Okay. Understood?
Yes, sir.
In that equation, apply the value of 4 in the place of x. Then you will get the first value in the y cap. Similarly, then apply the value of 9 in the place of x. Then you will get the next y cap. Understood? See, it's a tedious work, I know, but everybody should do that clearly. Okay, do that. And round the figures approximately for 2 digits. Round your figures approximately for 2 digits. Okay. So what you have to do is, in the first case, 0.485 plus 0.8871 into 4. Then the next case, that's the 4 is the first value of x, isn't it? We are replacing the value of x here. Then similarly, 0.485 plus 0.8871 into 9. By changing the value from 4931 such a way, you can find out the value of y cap. Everybody do that quickly. Prepare the column y cap. And if anybody got the first one, tell me the answer. What is the first figure? First y cap figure. Amu, you got it? 4.03. Okay. 4.03. I think now you understand that. Okay. So complete that column. Okay. Everybody got the 4.03 answer. So in this way, complete the y cap column. between this, I'm remembering you that after finishing the class, only after finishing this class, all of you should provide your name and roll number for attendance purpose in the group. Okay. Sometimes I forget to say that. That is why I'm saying this in advance. Not now, after finishing this. Okay, Ansarian. Ansarian says that he completed the figure. I think all of you completed this column. Any objection? Shall I proceed? Okay, Smita, okay, Rajisha. So I'm explaining further. Listen. Now you found out a y cap value, isn't it? Now we found out the y cap for all the 10 x values. Okay. Now the next column, which is error column. How we find out this error column? In order to get this error column, we use this the formula. I showed this in bracket, y minus y cap. See, first y is here, which is 3, isn't it? First y cap is there, which is, I think it is 4 point something. Somebody said that, which is 4 point something. In this way, you should take the difference between these two, y minus y cap. So y minus y cap column should be constructed by taking the difference between these y and y cap. And there is a chance of negative figure when you deduct 3 from yes minus 1.0 the first item, isn't it? So the first figure is minus. When you deduct this y cap from the corresponding y, there may be chance of negative figures also. So you have to take this negative sign value should also be there. Complete the error column. Complete the error column. After finishing that, say me yes. Then I can proceed next step. After getting it finished, say me yes. Okay, Shimja. Okay. Ranjusha. So I expect everybody finished with this. Done. Okay, Jisha. Okay. So now the error column. Now the error column is finished, isn't it? Now everybody come to the error square column. Error square means all the error value should get squared. Square all the error value. Okay. And then take the total of that column also. Square all the error values. Here error values there, isn't it? Then square the error values here in the error square column. And after that, take the total of that column also. And same with the total.
So can you please show once again?
This one, you got this error column, isn't it? Up to now, you finished the error column, isn't it?
Yes, sir. Yes, sir.
Each error value should be squared.
Okay.
Okay. Then take the total of that. And somebody shows that it is 21 point something. Square each error value and then take the total of this column. Show me the total of that column. Smita says it is 21.08. Okay. 21.08. Autobatates. Okay, Shimja. I think all of you finished with this and got the error square column total 21.08. Right? Shall I proceed? Okay, as there is no objection, I am proceeding to the next. Then the next column is total sum square. Okay, Shimja. Next column is TSS. TSS means the total sum of square. TSS column. TSS is shortly written here. Actually, it is total sum of square. Okay. And in order to find that figure, we require y minus y mean square. Y minus y mean square. That means it involves some difficult calculation. See, each y value, that means the first y value is 3. Isn't it? From what is the y mean? I think it is 4.3. I think y mean. Then 3 minus 4.3. Then 7 minus 4.3. By taking this value and then square the values also. 3 minus 4.3 and square that value. That is what? Y minus y mean the whole square. Okay. So every y value should be deducted from its corresponding y mean, and that value should get squared and complete the full TSS column. Everybody. If you didn't understand, just ask me. Otherwise, do this. And you take the total of this column also. Show me the total. Okay, Ranjusha. I am showing once more. See, take every y value. What is the first? Look here. What is the first y value? 3. Isn't it? 3 minus. What is the value of y mean? We found out the y mean there, isn't it? 43 by 10. That means 4.3. Isn't it? So 3 minus 4.3. Then again 7 minus 4.3. 2 minus 1. In this way, find these values and square the values also. 3 minus 4.3, that means 1.3. It should be squared. That is what y minus y mean, then whole square. That should be squared. Okay. After doing this, it should be total. Is it clear now? Okay, Ranjit. John Joseph, what do you ask? Is it 0? It's the total 0, no? TSS or John Joseph, TSS total is not 0. You will get a value. 76.1. I didn't notice your name. Somebody showed answer 76.9, isn't it? The total value of TSS, total sum of square, 76.9. I think that may be correct. 76.1, Smita. Okay, 76.1. Okay, Smita. Shimja. Okay, that's correct value. Okay. Okay. Shall I move to the next one? See, very few are responding properly. That is why I'm moving to the next one. I think all others are doing this because they are not asking any questions or doubts. So that's why I'm proceeding to the next one. Okay, Aji Mohan, Kavya Mohan, 76.0. Okay. Thank you. Now the next column, come to the next column, which is RSS is totally written here. Regression sum of square. RSS means regression sum of square. Okay, regression sum of square. See, the value that we found out by regression equation, which is y cap, isn't it? Y cap values are there in the column. After y, there is a column y cap, which is found out by using regression equation. You remember that? Y cap column is there. Okay, that y cap value should be deducted from y mean. Y mean means which is 4.3. All y mean are 4.3, and then take it square. That means from every y cap value, mean should be deducted and then square the value. Understood? Any question? If understood, complete this. Okay. If understood, complete this column and show me the total. Y cap minus y mean, the whole square. Show me the total of that column.
Sir, for example, first.
What is the y cap value? What is the
first one would be 4.0358.
4.0358 minus the y mean value is 4.3, isn't it? Y mean.
Okay, sir.
Take the difference. Similarly, do the whole 10 item. Okay, Amma. Okay, Aji. Okay. Show me the total of that column.
Sir, y cap എങ്ങനെയായിരുന്നു?
You asking me how to find out this y cap?
Yes, sir.
Kavya, I already told you that if you have any doubt, ask instantaneously, isn't it? See? Okay, come to this column, y cap. See, in this y cap column, we find how we find our y cap. Y is equal to a plus bx regression equation is there, isn't it? Do you have the regression equation with you?
Okay, sir. മനസ്സിലായി.
Yeah, in that equation, apply the value of x alternatively. Then you will get the values. You didn't finish with that?
Sir, sir, ഞാൻ കണ്ടില്ലായിരുന്നു y cap.
Okay. I didn't notice who somebody showed the answer. Did you show the total of that? Who answered that? Show me once again. $55.15. John Joseph says the answer of RSS is 55.17. 55.17. Okay, Shimja. Okay. 55.17. Okay. Okay. So we got all the values. Error square value 21.08. Am I right? Then total of TSS value, which is 76.1. Then total of RSS value, which is 55.12. Right? 55.12. Right? Now I'm going to the ANOVA table. Is everybody okay with this? Okay, Smita. Now we are moving towards the ANOVA table. Okay. Now look at this. See the regression equation. We are going to check whether the regression equation formed through formed through these regression equations confirm with the factor. That means the confirm with the hypothesis. Whether it is confirm with the hypothesis. That is why we are going to check with the ANOVA table. Okay. So everybody look here. I provide a heading here, ANOVA table, and 1, 2, 3, 4 columns are here. Source, then degree of freedom, then sum of square, then mean square. 4 columns are there. You notice this? Source, degree of freedom, sum of square, and the mean square. Okay. I explain this. Listen carefully. In the source, we are first we take a regression equation. Okay. So just write this as regression. In the case of this ANOVA table regression, we use degree of freedom always 1. That is why it is written here as degree of freedom 1. Okay. So the degree of freedom 1. Okay. Then the sum of square. In the sum of square, you have to write the value of sigma RSS. You took the total of RSS column, isn't it? What is the total of that RSS column you got? I think it is RSS column total. It is 55.12. 55.12. Yes. So which is you have to write 52.12, isn't it?
Right, sir.
55, isn't it? 55?
55.
Yeah, 55.12. So if we wrote this 55.12, okay? And in this next column, mean square, we use this formula, sigma RSS divided by degree of freedom. Sigma RSS means this 55.12, okay? 55.12 is the sigma RSS divided by degree of freedom here means 1. Degree of freedom is corresponding degree of freedom is 1. So we divide it by 1 and we get the same value 55.12. Is the first line clear? Okay. Now come to the next one. Under source, okay. Thank you. Okay. And under source, show error. Source error. That means we found out the error. Means the standard error. I already told you what is this error. At the time of calculation, when we compare the hypothetical frequencies with the observed frequencies, there may be chances of some error. That error was calculated by taking by considering the mean, etc. Okay. Now just write this error, and here the degree of freedom is n minus 2. Here the number of pair, which is n, which is 10. So 10 minus 2, 8 is the degree of freedom. 8 is the degree of freedom, isn't it? And in ANOVA table, always error is calculated by using the degree of freedom formula n minus 2. N means number of item. So number of pairs here 10. 10 minus 2 is equal to 8. 8 is the degree of freedom. Clear? Now you have to show sigma error square value. You totaled the error square value, isn't it? What is the total of that? It is 21.0908. Okay. Somebody shows it is 08. I am writing this as 21.08. Okay. Now, sigma error square divided by degree of freedom. So, 21 See this formula? Sigma error square divided by degree of freedom. We got sigma error 21.08 divided by, here the degree of corresponding degree of freedom is 8. So divide it by 8. Find the value. What is the value? 21.08 divided by 8. What's the value? 2.64. Okay, 2.64. Okay, Smita. Okay, thank you. 2.64 is the value. Okay. Now come to the last line, which is okay, Ajimo. Okay. Come to the last line, total. Under source, you have to show total. Then degree of freedom. Here 1 degree of freedom in the first line and the 8 degree of freedom in the second line. Then we total this, that means 9. 9 is the total of degree of frequency. Sorry, degree of freedom. Okay, 8 plus 1. Understood? It's simple. Then come to this sum of square column. Here the sigma RSS is 55.12 and error square is 21.08, isn't it? Total this two figures, 55.12 and 21.08. Total this value, Sami. It is 76.1. 76.1, isn't it? Now come to the table. What is the total value of the TSS? What is the total value of the TSS? Is it 76.1? Yes, right. That means if we done everything correctly, this total will matches with that. Okay. Automatically, we just added these two and showed here, which is sigma TSS. Okay. When we total sigma RSS with the sigma error square value, automatically we should get this value sigma TSS. That means then only the problem will be correct. Okay, some slight variations may be there for some point digits, 0.1, 0.2. It's okay. That is related to the rounding of that figure. And statistically, when we add this RSS with the error square, we should get this 76.1. And that was we found out by the TSS total. I think now this is clear with these aspects. Is it clear, everybody? Okay, Adi, okay.
Can you please share this page alone in the message?
This
how
page.
yeah, this one.
Okay. After this, I put it in the message. Okay.
Okay.
But I am explaining these things. Do you understand this?
So I have slight difficulty in understanding this.
Which aspect? Tell me, which aspect?
So after that, taking the degree of freedom 9, I didn't get.
This degree of freedom 9, we got the first degree of freedom in this column 1 and the next 8, isn't it?
Yes.
So 8 plus 1, 9, that's all. Just to take the total, which is total column. Understood? Understood or not? Hello?
Sir, I'm not familiar with the columns, that is why.
See, how many columns are here? Source, degree of freedom, sum of square, mean square. 4 columns are there.
Sir, signal is not clear.
Okay, sorry. Then I will put this page in the group. Okay.
Yes, sir.
My writing is not much clear.
Yes,
Even
sir.
after, it's okay. I put it there. No issue. See,
yes, sir.
Now we come to the last. One. F ratio. We are finalizing the ANOVA table by calculating F ratio. F ratio means we already studied about F test, isn't it? F test and F table is used here for this purpose. F ratio. To get this F ratio, the formula is regression on mean square divided by error mean square. This is the formula. Regression mean square divided by error mean square. Okay. Come to this column, mean square column. Come to the mean square column. Corresponding to regression, what is the mean square? We got 54.12, isn't it? That is the regression mean square. Corresponding to regression in the mean square column, by dividing this by degree of freedom, we got 55.12 by after division, 50.12. Okay, this is the regression mean square value. So 55.12 is the numerator. Then what is the denominator? Error mean square. So corresponding to error column in the mean square value
2.6.
which is 2.64. Okay, which is 2.64. 2.64. Just to divide these values and find the answer. 55.12 divided by 2.64. So 20.84. 20. Somebody shows a different answer. 20.84 is the answer. 20.87. Okay. 20.87 is the calculated value. Okay. This is the calculated value. Now we have to, okay, Mariam, okay. 20.87 is the calculated value. Now, listen, we have to look into the F table. I show you the F table at a 5% significance level. Here you can see. Can you see this?
Sir,
Yep.
one doubt, sir. For regression, is the degree of freedom always 1?
Yeah, of course.
Okay, sir.
See, F distribution table. We are taking F distribution table. See this at a 5% significance level. Since nothing is mentioned in the question, we have to take a 5% significance level. See, if 10% or 15% given in the question, then you have to move to that table. Okay, this is 1% significance level. That means this is 1%. So different tables are there, and here we are taking by default, and usually this 5% is sufficient for you. By default, we are using 5% significance level F table. Okay, here, what is the degree of freedom of regression? 1. What is the degree of freedom of error? It is 8. Okay, so regression degree of freedom, we say this as N1. Okay, just to say N1. And degree of freedom of error, which is 8. You can see that in the table. So N2 is equal to 8. N1 is equal to 1 and N2 is equal to 8, isn't it? So in this table, in the top of the left-hand corner, you can see N1 and N2. See this? Can you see that? N1 and N2. N1 horizontally, spread horizontally, and N2 goes vertically. So N1, our N1 is 1. So in the corresponding one column, N2 is 8. In the 8 column vertically, if you see this, you can find out 5.32 value, 5.32. Corresponding to N1 1 and N2 8, you will get the value 5.32. I think now you understood how to find out the value under F test. Okay, so we got the value 5.82. Now you have to write down this conclusion. That means at a 5% significance level, and the degree of freedom N1 1 and N2 8, and the degree of freedom N1 1 and N2 8, the F table value is 5.82. F table value is 5.82. Okay. Now we are going to compare the values. Our calculated value is, where the F ratio value is 20.87, isn't it? You remember our calculated value, F ratio value, isn't it? F ratio value is 20.87. Now the table value is 5.82. So the calculated value is more than table value, isn't it? So we cannot accept this. So we are writing the conclusion. Next line. Since since the calculated value 20.87 is more than the table value 5.82, the hypothesis is rejected. Okay. So that's all with this ANOVA table under regression analysis. Any question? Anybody?
Sir, one quick question, sir. When we considered the F ratio and we looked into the table, we are looking only for N1 and N2 value, right, sir?
Yeah, of course. The significance for each significance level, different tables are there. There is only one table for 5% significance level. Okay. And if it is for 10%, you have to look at another table. So the table changes according to the significance level. Here we just look into F test or F table with a 5% significance level. Okay. Is in there. We just look into degree of freedom only. N1 and N2 only. Understood?
Okay, sir. Okay, sir. Thank you.
Okay. Any question, anybody? No reaction. So I'm winding up the class. So by this we are finishing these topics. Okay. Thank you everybody for your cooperation. Okay, just put your name and roll number for attendance purpose. Okay, Shumja. Thank you.
Thank you, sir. Thank you.
Thank you.
Sure, sir. Thank you.
Okay.